Hi, my name is Jordan Stoner. I'm doing example 23, and that involves sigma notation and definite integrals, which is from chapter 4, section 2. So the first problem says find a definite integral equivalent to the limit as n goes to infinity, including the sum of n rectangles as I equals 1, 15i divided by n plus 2 times 3 divided by n. And then after you find an integral equivalent, you are supposed to evaluate the definite integral. So first, we're gonna look at this, and we're gonna notice that the integral as b goes to a f of x times dx is equal to the sum as the limit of n goes to infinity of I equals 1 f of a plus the change in x index times the change in x. So looking at that, we can see that the change in x is 3 over n, and a is 2 because it's being added to the change in x times the index. So the change in x is equal to 3 over n, a equals 2, b is unknown as of right now, although we do have the formula for the change in x, which is b minus a divided by n. So with that, we can put the change in x equal to b minus a, and a is 2. So we can solve for b here. So basically, we can just do 3 equals b minus 2, and b equals 5. So with that, we can start setting up our integral, which would be a is 2, b is 5, and f of x, we can just see that it would be x because there's no square roots or anything like that. So we're going to do x. And then we're going to do times dx. And that would be our integral. Oops. And then we have to evaluate the definite integral. So we are going. So to evaluate this integral, we're going to use u substitution. So first, u would be x, du would be, well, to find the derivative of that would just be 1 dx. So basically, dx would equal du over 1. So then we're gonna plug that in. So 5 to u du over 1, basically. Okay. And then we're gonna take the antiderivative of u. So the integral here. So that would be 1/2 u squared. I'm just gonna do du. So then you're gonna want to plug in a and b. So let's see, 5 squared is 25. Okay. And then subtract your a value. 2 squared is 4. And then you're just going to evaluate that. 25 minus 4 is 21. So 21 times 1/2 would just be 21 over 2. So this integral evaluated would equal 21 over 2. And that's all you have to do for number 1. And number 2 is a true and false question. and it's dealing with sigma notation. So we have to see true or false. Does the number of rectangles added up with I equaling 1, 6i squared equal n squared plus n times the quantity 2n plus 1? So to do this, we're going to have to use a couple properties. So with 6i squared, this is a constant. So we're just going to rewrite this real quick. So we're going to take out the constant and multiply it. So we'll have I squared. And with the index being squared, you can use, so basically I squared, you can use the property n times n plus 1 times 2n plus 1 divided by 6. So we're going to do, equals 1 I squared, gonna do n plus 1, 2n plus 1 divided by 6. So we're gonna take this 6 and multiply it, so we'll do that. And you can cancel out those. So then if you just simplify this, it'll be, distribute the n, it'll be n squared plus n times the quantity 2n plus 1. And so you can see that that does end up being equal. And that's all. Thanks for watching.